All right. Starting with some examples now. All right, let's do number 4 to start with. The sine of negative 165 degrees.
You know what I want to do with that? Sleep. Put it in my calculator.
Ow, my hair's stuck. Help.
Well, it's not going to do you any good.
I know.
All right, so big thing, we can't have negative angles. So how can I make that positive? That's equal to the same thing.
Give it the sine.
Terminal angles?
What is going
360.
on?
What?
Add 360. So negative 165 plus 360
Dude, stop it.
is what?
I'm not driving you around.
I don't need you to drive me around. I can drive myself. I think you
Hold on a second. I got it. It's because you have 195? I don't know. Is that actually right? I did it off the top of my head, so.
Yeah.
195 degrees. Okay, so now this is the part that you really have to understand. Okay, the angles, okay, that are up here as A and B have to be known angles.
Which ones have to be known angles? A and B?
A and B have to be known
What
angles
does it mean to be a known angle?
off the unit circle.
God.
Okay, so I need two angles that add up to give me 195 degrees. So I need my lovely unit circle from somewhere.
My unit circle is so beautiful.
All right, so I need things that add up to 195 that are on my unit circle. Okay, so there are different options, okay, or that can be subtracted. That works too. I usually tend to lean towards the adding.
That's just easier for my brain to work.
Okay, so I'm going to go to my unit circle, and I'm looking for things that I think would add up to 195.
150 and 45. Right? It's not equal 195.
That works. That's an option. Okay, just to show you some different options that works. 135 and 60 will work. You said 150 and 45. Okay, that works. Okay, but that will just show you that there's a lot of different options that will work for you. Okay, I mean, there's plenty more, but I'm not going to spend time going over every single possible option because there are a lot. Okay, so let's use the one Brooke said. Let's use 150 and 45. So we're going to rewrite this as the sine of 195, okay, is equal to the sine of 150 degrees plus 45 degrees. Okay, so I'm using these formulas up here, so it's going to be same sign because it's a sine problem. So it's going to be a decent amount. The sine of 150, cosine of 45, same sign, plus cosine of 150, sine of 45.
There, now I'm lost. So.
Okay, so this is from the formula here. So this is the sine of A plus B. So sine of A, cosine of B, plus cosine A, sine B. Okay, so now on the unit circle, you're going to find 150 and figure out what the sine value is. Okay, in this case, it's 1/2. The cosine of 45 is root 2 over 2. Plus, the cosine of 150 is negative root 3 over 2.
I'm so dumb. I literally wrote r square root of 2 over 2 because you said root and.
And the sine of 45 is root 2 over 2.
I don't like this.
Okay, so I'm going to let everybody get this down, and then I'm going to talk through combining
I wrote
these.
R under.
This brings me great sadness. I just let you know.
You know, I'm trying to like.
These are the easy ones, so I hope these don't make you sad.
I like it, Miss Earhart. I'm not crying yet.
It's got several 5s in it for
I
you.
know. That's like makes
Brooke
me-
picked numbers that gave you 5s.
You're welcome.
All right, do we have this?
Yeah.
Here. All right. So, on top, okay, these are multiplying. So 1 times root 2 is root 2. 2 times 2 is 4. Plus negative root 3 times negative root 2 is Negative root 6 over 2 times 2 is 4. Now I can combine these to root 2 minus root 6 over 4.
Whoa.
And that's your answer. Now, your hint is going to be that your answers are going to always include numbers that look like this. If you get something like the square root of 27, you've done something wrong.
Okay.
Okay? Your favorite numbers for this section are going to be square root of 2, square root of 6, 4, and then when we get to tangent, square root of 3, 1, and 2, I think. And the number 3 maybe, because of the bottom. Anyways, you'll see it when we get there. But if you get something with sine and cosine that's like the square root of 27, something's wrong. Okay, your answer is going to be some combination of these numbers. Or potentially just a 2 on the bottom, depending on what values you're using. But anyways, these numbers in general are going to be your favorite numbers.
I like
this
this.
section, okay? So unfortunately no 5s, but
The 5s could be in the top part.
up there, yes, but down
Yeah.
here, no. All right, let's do another one. 6. Cosine of 15 degrees. Okay, this one is positive, so I don't need to like add 360 or anything. Okay, now, is the cosine of 15 something that I know?
No.
No. Okay, so there are multiple options again that I could pick for what to use. Okay, in this case, I don't have anything that can add to give me 15. Okay, I don't know like 10 degrees and 5 degrees, so I'm going to have to subtract. Okay, I always recommend using numbers that are in the first quadrant if possible, just because it eliminates the potential negative signs that come with things. Okay, so to get 15. Okay, 45 minus 30, 60 minus 45. Okay, things like that. I'll use the 45 minus 30.
I was so excited to say that. I'm very
Me
excited.
too.
So this is the cosine of 45 minus 30. Okay, and in a minute we are going to get some that are in radians. I'm just going to forewarn you now.
I don't like
Okay, but I'm not mean about it. I actually let you convert them to make your life easier.
Oh.
Okay, cosine of 45 minus 30. So again, I'm going to go up here and I'm going to find my formula. Okay, remember with cosine, I'm using the opposite sign and it's the buddies are grouped together. So the two cosines together, the two sines together with the opposite sign in between. Okay, the opposite SIG in between. Okay, so this is going to be the cosine of 45, cosine of 30. It was minus, so plus sine of 45. Sine of 30. And what is the cosine of 45?
Root 2 over 2, right?
Root 2 over 2. Cosine of 30.
Root 3 over 2.
Root 3 over 2. Plus sine of 45.
Root 2 over 2.
Root 2 over 2. And sine of 30.
1/2.
1/2.
This isn't that hard. I'm just making it hard.
Okay, so root 2 times root 3 is root 6. Over 2 times 2 is 4. Plus root 2 times 1 is root 2. Over 2 times 2 is 4. Combine them, and you have to combine them to have it completely right. Okay, root 6 plus root 2 over 4.
Yes. I understand, which is really scary.
This is good for me. I understand right from the beginning.
Yeah, I know that never happens to me. I'm scared now.
This negative attitude is no good.
I'm just
This
scared.
negative attitude.
I was gonna ask you a
It's
question and I
tangent, man.
forgot.
Change, man.
Oops.
All right, this next one is going to be very important that we pay attention because it's going to be a tangent one and it's in radians. Okay,
Go team.
so does everybody have this
Oh,
one
yeah.
first? Okay,
Yes,
because I don't
ma'am.
want to move on to that one without people being done with this one.
Okay, I got it.
This will probably be the last problem we do today. Okay, and then tomorrow we'll do some more and probably finish the section on Wednesday. Tomorrow will probably take a decent amount of time to do this section, and then Wednesday will be your like homework work day
This class period has gone by like really fast.
Yeah, I agree.
because we went over the quiz.
It's
It
because
takes a
we
long time.
all actually understand it.
I don't know. Usually, I
always
feel
takes
like
us
if we go over like the quiz before, it takes like longer.
The tangent of 17 pi over 12. Okay, so I said this one's in radians, okay? I don't know if you guys know what adds up and gives you things that you know in groups of 17 pi over 12 or pi over 12 increments, okay?
Yeah, definitely don't know that.
I don't really like doing radians and having to do the reverse of trying to figure out common denominators that add up and give me that.
What?
It's just really annoying. Yeah, exactly. So, so I am nice and I'm going to let you convert it, okay, 2 degrees. So somebody walk me through how to convert 17 pi over 12 to degrees.
17 pi over 12. The little conversion sign thingy bubble, you know what I mean? And then you have
180 over 5.
Yeah.
Yeah.
Then you start canceling things out.
Okay.
Multiply 180 times 17 divided by 12.
I would cancel out
But you
12
can
when
cancel out your
like
12
trying to
at home.
reduce it.
You can, but you can also just type it in your calculator.
My calculator's dead. My Here's where my best friend comes back. You know, little calculator buddy.
That's why I said you can use him, but he might not be super helpful.
Mine is doing that flashing thing again, like when it turns on.
What'd you get?
Turns on.
255.
255.
I feel allowed to have this thing.
It's like a
Next year, you pretty much are.
Yeah.
Really?
Yeah. The ginger on my calculator is
It's not a hit.
nail.
What?
Fantastic.
How can you tell?
Okay, so 255 degrees. So I now am dealing with the tangent of 255. And so I need to know what that can be broken up into. Okay, 2 pieces that add up to give me that, or I guess I could subtract. I would say probably go with adding.
I'm actually like not sure.
Well, obviously it's 40
Okay, 45 will be one of them.
and 210, right?
Yeah, 210. Okay, now there are other options again, but that's probably the easiest one.
I did not even see the 45.
I think for
anymore.
me the hardest part is gonna be trying to figure out how to get
Me too. How to break it up.
155. Like other than
Yeah,
that.
your unit circle will be your best friend besides your calculator.
I need to remember
Besides
to
the
grab my
calculator.
unit
And just to be
circle
sure, you
so-
are giving us a unit circle.
This chapter you get a unit circle for.
I like doing stuff like
The
that.
exam you'll get a unit circle.
I completely forgot about the exam. Like usually it's just like do it for the test and then the test passed and then I'm like, okay.
Alright, so for this one, okay, I'm back up here for my tangent. Top sign is the same, bottom sign is opposite.
God bless you.
So I've got the tangent of 210 plus the tangent of 45 over 1 minus the tangent of 210 times the tangent of 45.
Oh no. Wait, can you, everyone, nobody say anything? I haven't finished writing the, you know. Okay. So
I'm digging these vibes.
Okay, so the tangent of 210 is
root 3 over 3.
root 3 over 3
Oh man.
plus the tangent of 45
Oh, I see.
1.
over 1 minus the tangent of 210 we already said was root 3 over 3. Okay, times 1. So this is root 3 over 3 plus 1 over 1 minus root 3 over 3.
Okay, would that equal?
Okay, so my first thing, here's my recommendation. Yes,
How'd you get root 3?
off the unit circle
You get the tangent bit.
255.
from 210.
From 210, okay.
All right, my recommendation, first of all, to make your life easier is going to be to get a common denominator on the top and a common denominator on the bottom. It's going to happen to be the same one, which is going to be nice in a minute. You'll see why.
3.
Okay? 3.
So it's 3 over 3.
She just finessed the whole thing.
All right, root 3 plus 3 over 3 all over, okay, again, 3 on the bottom, 3 minus root 3 over 3.
What? Where
I
did we
feel
get
super
that?
upset.
Okay, 1 is going to be replaced by 3 over 3 on top and bottom, and then I can do that.
Okay. Hold on, let me write that bit down.
So then you just put it all together and then put the, ooh, yeah, I got it. I got there.
Okay, well, I'm dividing by a fraction, which means I need to do what?
Multiply by the reciprocal.
Multiply by the reciprocal, so I now have, oh, stop that.
Oh, that was just scary.
Root 3 plus 3 over 3 times 3 over 3 minus root 3. 3's cancel, leaving me with root 3 plus 3 over 3 minus root 3.
What?
Now, does that cancel?
No.
No. No, it does not.
Different signs, right?
Does not cancel.
Okay, I'm going to now multiply by
Another reciprocal?
the conjugate.
Oh god.
No. Oh.
3
Ooh.
plus root 3 over 3 plus root 3.
Can we back up? I'm still on.
Yes, I will pause there for a moment.
So root 3
Until it comes back to
plus 3 is equal to 3 times 3 minus root 3.
We can do cosine instead.
Then what do you do?
Why did we do the plus string on a minus string on the conjugate? Never mind, because it's on the bottom and you're trying to eliminate. I got there.
This is not working out.
Then you multiply by the conjugate, which is, oh my goodness.
Oh.
That was a quiet one.
Okay, I've got it written down now.
All right, so now I'm multiplying. Okay, it might be easier just, okay, you don't have to do this, but it might be easier to rewrite this top as 3 plus root 3. It might not stress you out so much if you write it the same direction. I don't know. It doesn't really matter.
It all stresses me out.
I'm just saying it might help you a little bit to rewrite it. Okay, the top. Okay, we're foiling. Okay, so
No.
3 times 3 is 9. 3 times the square root of 3 is plus 3 root 3. Another 3 times the square root of 3, so plus 3 root 3. Plus the square root of 3 times the square root of 3 is 3. On the bottom, this is a difference of squares, so it's going to be 3 times 3, which is 9, minus the square root of 3 times square root of 3 is 3. So then on top, I've got 9 plus 3 is 12, plus, okay,
Is it 6?
yes,
over 6 root
yes,
3?
6 square root of 3, over 9 minus 3 is 6.
Can you take a 6 out
Okay.
of the top?
Yes, because both pieces have something that can be a factor of 6. I can take a 6 out. So this will be 6 times 2 plus the square root of 3 over 6. And now I can cancel the 6's. Okay, they go away,
Oh, you can't just take them out.
leaving me with 2 plus the square root of 3.
That was totally not fun at all.
That took a whole page.
That took a whole page.
Okay, the tangent ones are the hardest. They are the longest. Okay, and their answers will look something like this. Okay, on occasion you get something else mixed in there as well. But it's usually like 2 plus the square root of 3 or 2 minus the square root of 3, or maybe the other way around depending on how things cancel out and stuff. But because of the nature of their formulas, that is what is going to happen. Okay. So if you want to be able to start working on problems, like I said, you'll have time, but if you want to be able to start working on them, you're going to do 3, 7, and yeah, 3 and 7.
And
That's it. Just 3 and 7.
Okay. I'm oh.